All right, hello, ladies and gentlemen. I missed you all. I hope you're doing well. In this trigonometry unit, I am going to be teaching two new things. They are the things that make trigonometry valuable, and they're the last two things that really make me think that I taught a full course in trig. I'm super sad we didn't quite get there, but I'm going to show them to you a little bit later on. So here we're looking at IXL Skills M1, M5, and M12, which is converting between radians and degrees. You already know how to do that. Evaluate and simplify your trig ratios. You already know your trig ratios, so that shouldn't be hard. And then solve a right triangle using trig. Again, it shouldn't be hard. What will be hard is give exact answers. So on this last skill, which is M12, you do need to remember your 30, 60, 90 and 45, 45, 90 trig ratios. And so I did a little simple triangle here that represents a 30, 60, 90 triangle. And it's important that you know a 30, 60, 90 has a short side, a middle length side, and a long side. And if you're given a triangle, and maybe you don't know that it's a 30, 60, 90, but if you see a side length of 15 and a side length of 30, you have a side length of x and you have a side, the hypotenuse, which is twice what your short side is. And if you know that, then you know it's a 30, 60, 90. And so that's really, really important. And so then we can also figure out this middle length side by just taking your short side and multiplying it by radical 3. So this would be the short side times radical 3, or 15 radical 3. So those kinds of things are important to realize. The same is true over here. If you have a 45, 45, 90 triangle, maybe you don't know that it's a 45, 45, 90 triangle necessarily. You know you have a right angle. But if you know that you have a side length of 14 and a hypotenuse of 14 radical 2, then you know absolutely that it must be a 45, 45, 90 because they're all that way. This other side then would have to be 14 as well. So pretty cool that you can pay attention to those sorts of things. And it can help you out with exact answers. So keep that in mind. Let's do a little bit. You will need your calculator. So we are converting for the first thing. How many degrees is 10 over pi radians? So our conversion factor, we know that pi radians is the same as 180 degrees. And we're going to take that to convert pi over 10 into degrees. And to convert things, we just multiply. We're multiplying by unit factors, unit fractions rather. So this is radians, and I want degrees. So I'm going to put 180 degrees on top and pi radians on the bottom. And we'll know those radians cancel out, so we can reduce our pi's. Pi on top and pi on bottom reduce. And then 180 divided by 10 is 18. So divide by 10, we get 18. Divide by 10, we get 1. And so we have 1 times 18 is 18 degrees over 1. So that was not too hard. So 18 degrees. Over here, how many radians? So we have negative 198 degrees, and we want to multiply by our little conversion unit here. We want radians. So I'm going to put pi radians on top and 180 degrees on the bottom. And that way, our degrees on top and degrees on bottom cancel out, leaving me in radians. This is 198 over 1. And I'm just going to multiply straight across. So negative 198 times pi divided by 180. Now this is not an acceptable answer. You must reduce. And the easiest way to reduce is actually just to put this little fraction in your calculator. Ignoring the pi, I'm just going to put it into my calculator. 198 divided by 180. This is definitely the cheater's method. And I get a decimal, but that's not okay. We're going to math frac it. and that's going to be a negative. That fraction turned into 11 over 10. And then don't forget your pi. And so be careful when you're typing it in. I'm not exactly sure how IXL is going to do this, but you have to think this is pi over 1. So pi needs to be in the numerator. So probably, you know, I would make sure that you do negative 11 pi over 10 in IXL. You might also be able to type it in negative 11 pi divided by 10, just using a forward slash as well. So either way. All right, ladies and gentlemen, that's the first skill. Hopefully that's pretty easy. Math frac, and remember on your Casio calculators, you could do the same thing. You just need to make sure you do 198 divided by 180. Again, you get 1.1, and you just have to do the fraction decimal button. So, and that's 11 over 10. So really easy. Use those math frac buttons. That'll be real useful to make sure that you fully reduce. Example 2, find the indicated ratio. Fully simplify, do not round. Again, you can pause this video to draw your triangles and then start it whenever you're ready. So we want to find the cotangent ratio. Cotangent, so TOA, TOA. All right, so we know SOHCAHTOA. Cotangent is the reciprocal of opposite over adjacent, so that must be adjacent over opposite. Looking from angle K. So looking from angle K here, I need my adjacent side and my opposite side. So here is my adjacent side, and here is my opposite side. And so first, I need to figure out this opposite side. And to do that, we can use our Pythagorean theorem. So legs squared plus, I'm just going to call this y squared equals hypotenuse squared. 20 squared is 400. I don't know what 52 squared is. 52 squared is 2704. And I'm going to go ahead and subtract 400 minus 400. I get 2304. I wonder if that has a square root. Square root of my answer. Oh, it's 48. Look at that. So I'm going to take a square root of both sides, and I get 48. So y is 48. That's handy. There is probably a faster way to do that, but that's okay. And then I need to figure out my cotangent ratio, which should be adjacent over opposite. So the adjacent side is 48. My opposite side is 20. And you must reduce, ladies and gentlemen. Reduce, reduce, reduce. So again, your handy dandy calculator, 48 divided by 20. And then math frac it, 12 over 5. And so that's what we would want to input in your IXL program. All right, so first of all, here we want the sine ratio. Sine is opposite over hypotenuse, and this is according to angle y. So looking from angle y here, our opposite side is right here, opposite over a hypotenuse. And maybe you're noticing that this has some interesting side lengths. First of all, 10 radical 7 and 10 radical 7 are equal. So this is a 45, 45, 90 triangle. You can also see that this side, if I take 10 radical 7 and multiply it by radical 2 to get my hypotenuse, radical 7 times radical 2 is how they get that radical 14. So that goes back to my 45, 45, 90, which was x and x for the isosceles portion, and then x radical 2 for the hypotenuse. So just taking that side and multiplying it by radical 2 is how we get that radical 14. So let's see what happens when we try and simplify this. So the opposite side is 10 radical 7, and the hypotenuse is 10 radical 14. There's lots of ways to simplify this, but I'm going to show you a kind of a cool trick. It comes from knowing that this is multiplied by radical 2. So 10 radical 7, radical 14 can break apart into radical 7 times radical 2. That's really quite handy. Those are equivalent statements, right? Well, 10 divides by 10, that goes in one time, and radical 7 over radical 7 also reduces to 1. So I'm left with 1 over radical 2. Again, this is not an okay answer. IXL will not take this. You must rationalize. So reduce first for sure, if you can. So that's a handy little trick there. So we're going to rationalize. I'm going to go ahead and multiply top and bottom by radical 2 to rationalize. 1 times radical 2 is radical 2, and radical 2 times radical 2 is radical 4, which simplifies to just be 2. Square root of 4 is 2. So you probably all knew it was radical 2 over 2. And that is an appropriate answer to put into IXL. So it must be rationalized. It must be reduced. So definitely reduce first if you can, and then think about rationalizing if you need to. I have another one of those. All right, so sine according to angle R. So looking from angle R, we want the sine ratio. Sine is opposite over hypotenuse. So that would be my opposite side over here and our hypotenuse, which is 4 radical 5. Well, in order to do this, I need to figure out this third side. So once again, we're going to use the Pythagorean theorem. You can see these numbers are quite uglier. So let's see, we're going to do leg squared plus leg squared equals hypotenuse squared. Now you've done stuff like this, but it's been a while. Radical 22 squared is 22. Radical 22 times radical 22 is 22. Plus y squared. And then 4 radical 5 times 4 radical 5. Let me write it out. Well, that's 4 times 4, which is 16. And then radical 5 times radical 5, which is 5. So 16 times 5 is 80. I better check that. I think it's 80. 16 times. I don't have any of you to help me out here. It is 80. Oh, good. Okay. I'm going to go ahead and subtract 22. What is that? 60, 58? Yeah. All right. And then we can take a square root of both sides. Oh, my goodness. So the square root of 58. Oh, geez. Let's see. 58. You know, I would say leave it, but IXL won't say that. So 58, I know, is divisible by 2. Oh, 2 times 29. Well, that's good. That means I cannot simplify it. So there aren't any perfect squares in there. 29 is prime. So it's going to stay radical 58. I'm just going to double check. 80 minus 22. I just don't trust myself these days. Okay. Oh, good. Okay. And now we can go ahead and figure out our sine ratio, opposite over hypotenuse. So radical 58 over 4 radical 5. And again, this is not okay. You cannot leave your answer like this. You have to rationalize. I maybe would try to reduce if I could. But again, 58 is 29 times 2. So I know I don't have any radical 5s that I can reduce that with. So we do need to rationalize. So I'm going to multiply top and bottom by radical 5. The 4 is fine. Don't touch the 4. Leave the 4. And then when I do this, 4 times radical 5 times radical 5 is 5. Times the 4 gives you 20. So these two together is 5 times the 4. All right. And then on top here, we have 58 times 5, which is 290. And I need to see if I can simplify that. I don't think so. I know it's divisible by 10. Yeah, so this is 2 times 5 times 29. Those are the prime factors. There's no perfect squares there. So this is fully simplified. And that is something you could put into IXL. So always looking to see if you can simplify. but that doesn't have any perfect squares, so it doesn't go any further. All right, example 3, solving the right triangle. So for a couple of these, again, using those 45, 45, 90s and 30, 60, 90s is really, really important here. So they tell you in the directions, do not round. And if they're telling you do not round, it must be because it's a special right triangle. So you can see here we have a 30, 60, 90. This is our hypotenuse. Our hypotenuse is 90. And in our little 30, 60, 90 sketch here, if you had a 30-degree side, it was x, then the hypotenuse was twice that length, and the middle side was x radical 3. So what I want to do, if I know that I have the hypotenuse, this is twice my smallest side. My smallest side is over here. So I'm just going to divide it by 2, and that's going to be 45. And, well, if I know the smallest side is 45, then I can get my middle length side just by multiplying by radical 3. So 45 radical 3. So that's pretty handy if you know that you have a 30, 60, 90. The hypotenuse is twice the small side. All right, so that says BD is 45. BC is 45 radical 3. And the measure of angle D, well, that's easy to find. The measure of angle D, we know that a triangle has 180 degrees. We're going to subtract our 90-degree angle, and we're going to subtract our 30-degree angle, which means it must be 60, which you probably already knew that anyway, because it's a 30, 60, 90, obviously. 30, 90 must be 60. All right, let's look. Oh, oops, that can't be right. Sorry, I don't know how I wrote 20 there, but that should be a 10. I apologize. All right. So now we have another type of triangle here. And again, they didn't give me any angle measures here, but they're telling me not to round. So I'm thinking maybe it's a 30, 60, 90 or 45, 45, 90. Well, since I have the hypotenuse here and I have this short side that is half the hypotenuse, 10 times 2 would give me my, I know this must be a 30, 60, 90. So I've got my short side of 10, my hypotenuse of twice that number. Very good, which means that this must be our middle length side, which means I just need to take my short side times radical 3. So 10 times radical 3 is 10 radical 3. If this is my short side, it has my shortest angle, smallest angle, which must be 30 degrees. And here must be my 60-degree angle. So I know that IJ is 10 radical 3. The measure of angle J is 30 degrees. And the measure of angle K is 60 degrees. So kind of nice. Knowing those 30, 60, 90, and 45, 45, 90s is really good. The last kind you'll see here, they're telling you, hey, you have to round to the nearest tenth. And that's because we're using numbers other than 30, 60, and 45. So know that if they're telling you to round, it must be because, hey, I'm going to have to use my calculator. Now we are going to have to use some trigonometry to figure out these angle measures. First, I know I can figure out the measure of angle T. The measure of angle T, well, that's pretty easy. We know a triangle has 180 degrees minus our 90-degree angle minus our 25-degree angle. And so I'm just going to use my calculator, 180 minus 90 minus 25, and that is going to be 65 degrees. So I know that measure of angle T is 65 degrees. And now I can figure out this some side lengths just using some trig. I'm going to use the angle they gave me. And just in case I made a mistake, but hopefully you aren't going to make any mistakes like that. I want to find this side over here. I'm just going to call it question mark for now. And again, they're saying round to the nearest tenth. So I have this side, which is opposite my 25-degree angle, and I have this hypotenuse of 7. And so opposite and hypotenuse is a sine ratio. So the sine of my 25-degree angle would be what I want to know divided by 7, opposite over hypotenuse. And then I can solve for my question mark pretty easily just by multiplying by 7. So my question mark is 7 times the sine of 25 degrees. So using your calculator, you want to make sure that you are in degree mode. If you have a Casio, then under setup, so setup, you have radians and degrees. You want to make sure that you're in degrees. And so we have 7 times the sine of 25. And so we get 2.95. They want us to round to the nearest tenth. So we go to the hundredths place and say, if you're 5 or more, then you round this guy up. Well, to round him up becomes 3.0. So our side UT or TU is 3.0. Now I can do the same thing to figure out this adjacent side. So we want to, I don't know, I'm just going to call it a star. We want to figure out the star here. And so I have adjacent and I have hypotenuse. Well, that's a cosine function. So the cosine of my 25-degree angle is adjacent over hypotenuse. So again, I just want to isolate my star. So I'm going to multiply by 7. So the star is 7 times the cosine of 25 degrees. So again, go to my trusty rusty calculator. Excuse me. 7 times the cosine of 25. We get 6.34. So we go to the hundredths place. It is smaller than 5, so this stays the same. So we're going to keep it 6.3. So this equals 6.3, and that is what we would type in to IXL. Be very, very careful with rounding. That is super frustrating. Believe me, I know. I've done it. Where you get everything right and you're off by 1,000th. It's very frustrating. So save your rounding to the very, very end, and be very, very careful. All right, ladies and gentlemen, so that's skills M1, M5, and M12. And again, you can strive for scores that are much higher than your percentage, and your grade will come up faster and faster and faster. So take your time and have a great day.